So today we're going to be doing assignment number 6 in our unit 4 on matrices, and we're going to be solving not only 2x2 systems with a calculator and by hand, but we're going to be solving 3x3 systems. Now the expectation is going to be that when you do a 2x2 system, you're going to be able to do that by hand. But then anything that's 3x3 or even larger, then you will be able to use your graphing calculator to do those. So let's go ahead and get started. We're going to start with this matrix or this system of equations that we want to solve, but we're going to solve it by transforming it into a matrix equation. And we're going to do that by coming up with 3 matrices: a coefficient matrix, a variable matrix, and an answer matrix. The coefficient matrix is the matrix that is going to be made up of our coefficients. The coefficients are the numbers that we're multiplying the variables by, like the 5, the 2, the 8, and the 4. So it's simply going to be 5 to -2, and then 8 and -4. Our variable matrix is x and y, and our answer matrix is going to be 1 and -4. And the reason this works is because when I multiply this row by this column, I'm going to take 5 times x minus 2 times y equals 1. That's this equation. 5 times x minus 2 times y equals 1. When I multiply this row by this column, it's going to be 8 times x minus 4 times y equals -4. That's the same thing as this equation. 8 times x minus 4 times y equals -4. And so this matrix equation is the exact same thing as this system of equations. And so we can solve this then by hand. We would first have to find the determinant. And so the determinant is going to be 5 times -4, which is -20, minus 8 times -2, which is -16. And -20 minus a -16 is -4. Then we're going to take 1 over the determinant and multiply it times a new matrix. So the -4 and the 5 will switch places. The 2 will become positive and the 8 will become negative. So when I multiply -1/4 times that, I'll have 1 and then -1/2 and then +2 and then -1/4 times 5 is -5/4. And this is our inverse matrix. I'm going to call it a to the -1st. So if this is A, our inverse of A is this matrix. And so essentially then what we really need to do, if I multiply this equation by the left-hand side, the A times the inverse of A would be 1, 0, 0, 1. 1, 0, 0, 1 would just give us the matrix x, y. And so then I would multiply the inverse of A times the other side of the equation, which is 1 and -4. And if I do that, then I will know what x and y is. I'm going to start by multiplying this row times this column. 1 times 1 is 1. -1/2 times -4 is +2, so that gives us 3. Then if I multiply this row by this column, 2 times 1 is 2. -5/4 times -4 is +5, and 2 plus 5 is 7. And so we know that x is 3 and y is 7. We can do the same thing by using our calculator. And if we use our calculator, I'm going to say that our coefficient matrix, which is this one right here, we're going to call that matrix A. Our variable matrix, instead of having the elements be variables, we're going to have the entire matrix be a variable, x. And then our answer matrix is going to be this matrix here, which is 1, -4. So with our calculator, we're going to enter matrix A first. So if you haven't done this before, you want to, let me clear all this. You're going to go to your second matrix button, which is right here. We're going to choose matrix A. We're going to edit it. And so I've already done this problem once, so mine's already in there. It's a 2x2 matrix. And so if you don't have these in there, you want to put 5, -2, -8, and -4. That's matrix A. Then you want to go to matrix B. And so you're going to edit it. You're going to go down to B. And we're going to edit matrix B to be a 2x1 matrix. It's this one right here. So it's 2x1, and we want it to be 1 and -4. Then really all you have to do is, I'm going to get out of this mode. I'm going to go to second quit. I'm going to go to matrix A, but I want the inverse of that matrix, and my inverse button is right here, x to the -1st. So now I have the inverse of A, and I'm going to multiply that times matrix B. And when I do that, you see that I get 3,7, which is the exact same thing that we had when we did this by hand. So now what we're going to do is we're going to continue with problem number 2. So this time I want you to solve this entire equation with your calculator. This is a 3 by 3 matrix, and so the first thing we'd have to do is to translate this into a coefficient matrix. To a coefficient matrix, which we have here. Our variable matrix, I'm just going to call it X, and then our answer matrix, which is 20, 2, and 2. So to do this, we're going to go back to our calculator, and I'm going to go to the matrix button again, and I move over to edit. I'm going to edit matrix A, and I'm going to call this one a 3 by 3 matrix. And now I'm going to enter all of those elements, which is 3 and 2 and 1, and then 2 and -2 and 1, and then 1 and -3 and 2. And I'm also going to edit matrix B, except this time I'm going to call matrix B a, oops, I want to go to matrix B, so let me go back to matrix B. I'm going to scroll down to B. This is a 3 by 1 matrix, and I want it to be 20, 2, and 2. And so to solve this three-dimensional systems of equations, I'm just going to go to matrix A and click on inverse. Oops. Let me go back here. I got ahead of myself here. Let me clear this. And I want to keep that as a 2. Get out of this mode, and now I'm going to go to matrix A. I'm going to go to matrix A, but I want the inverse of that, so I'm going to click on inverse, and I'm going to go to matrix B. So I'm going to scroll down here to B, and that gives me the answer, which is 2, 4, 6. So solving a 3 by 3 system of equations is really that easy. Okay, so let's go on to our next problem here. This is a challenging one. We've never done a 4 by 4 system, and that's what this is. And it's not set up for us, so we'd have to set it up ourselves. And so we're going to have really 3 equations here, and our equations are going to be based on the candy bars, the popcorn, the Cokes that people buy, and the packs of gum. So it says that Tony bought 2. I'm going to let the candy bars be X, the popcorn be Y, the Cokes be Z, and packs of gum, I'll let that be W. So this is out of order, but that's okay. We're going to have 2 X's for what Tony bought, plus 3 popcorns, so 3 Y's, plus he bought 2 Cokes, that's 2 Z's, plus a pack of gum, so that's plus a W. And he bought all of that for $8.60. Then Tina bought 5 candy bars, bought a candy bar, so that's X, plus a popcorn, so that's Y, plus 5 Cokes, that's 5 Z's. Doesn't say anything about any packs of gum, so 0 W's, and she spent $9.50. Then Troy bought 2 candy bars, so that's 2 X's. He bought 2 popcorns, so that's plus 2 Y's, and 5 packs of gum, so no Z's, but I'm going to keep this in order here. 5 packs of gum, that's 5 W's for $5.75. Then Tyler bought 3 popcorns, so no candy bars, so it's just 3 popcorns, plus 3 Cokes, that's 3 Z's, plus 3 packs of gum, that's 3 W, and he spent $9.30. So there we have our 4-dimensional system of equations, and we would want to set that up as a 4x4 system, it's going to be 2, 3, this is a 2 here, 2 and 1, and then a 1, 1, 5 and 0, and then a 2, 2, 0 and a 5, and then a 0, a 3, a 3, and a 3. Times x is going to equal our answer matrix, which is 8.6, 9.5, that's a 5 there, 5.75, and 9.3. So we will call this matrix A, we'll call this matrix B, and we'll just multiply them together on our calculator, the inverse of A times B. And I believe if we do that correct, if I've set everything up correct, a candy bar is going to be 75 cents. Popcorn is going to be $1.25. A Coke is going to be $1.50. And a pack of gum is going to be 35 cents. And you can do that by doing the inverse of A times B on your calculator. Good luck, and we'll see you tomorrow in class.